All right, welcome, and I hope you're ready to do some algebra. So as you can tell, I have my party dog background ready and waiting for us, and we are going to be working on lesson 9-1. Now before we start, I just want to point out that I will be making mistakes. My lines will not be straight. My handwriting will be sloppy. But for the most part, you should be able to understand it. If you do not understand it, that is absolutely okay. Just go ahead and send me an email or leave a comment or whatever you want to do. All right, so before we even get into the lesson, I'm going to cover some things on my notes. Just basically things you should know before going into the lesson, things that are in that little box that you guys usually skip over without reading. So feel free, you can take your own notes, you can take a picture of my notes, you can pause the video, you can come back to this video as needed. But these are the notes. I will reference these throughout this video, but I will bring this sheet back. All right, so understanding my notes. We have standard forms for quadratic equations. Again, this is a quadratic because that has a squared. Now, you don't need to really remember too much of that, just know that the standard form starts with the x squared and goes lower and lower. So y equals ax squared plus bx plus c. Now, on all of the examples we do, you're going to see a, b, and c as numbers. They're not really going to show you a, b, and c. One of the problems this lesson does talk about c, but I will go over that. So here are some examples. I used the examples from Canvas, so you can see them a little bit clearer here than in that box. They kind of zoomed out a little bit just because of the formatting. So we have y equals 5x squared, okay, where 5 would be a, b is 0 since it's missing, and c is 0 since it is missing. Example 2, y equals x squared plus 7. Now I like this one. It's a little tricky. B is going to be 0. Why? Well, because b is supposed to have a single x near it, or a variable. There is no single x here. We have an x squared and we have just a number. So b is missing. bx is missing. So that makes this positive 7, our c value. And then number 3, we have x squared minus x minus 3. This is another one I like because it really shows what a, b, and c are. So a would be 1, b would be -1, and c would be -3. Okay, so this is just something that you should really understand and be able to see, not necessarily memorize. Here is something more for you to memorize. So as we go through this lesson, you're going to graph quadratic equations. They're going to produce parabolas. What are parabolas? Sad faces and smiley faces. So on both sad faces and smiley faces, we got vertexes. Now, it's very clear here because I put a point. Now, when we go through Canvas, it's not going to have a point. I just added the point to make it very clear. So it's just either the top or the bottom of each graph. So this will be the vertex on this, and this will be the vertex on these types of problems. Now, under here, we have maximum and minimum. So we're going to have to understand that graphs that are sad faces or downhill ones or whatever you really want to call them are going to have maximum values, meaning it goes to this point and it goes no higher. It's all downhill from here. So that is going to be a maximum point. And then we have a minimum. Well, it goes downhill and stops. This is the lowest part of this graph, and then it will continue upward. So this will be a minimum. Again, we're going to need to reference these for about 4 problems in this lesson and an abundance in your practices. All right, moving on to the next section. So y equals 3x squared minus 2 and y equals x squared minus 4. These are pulled right from problems 3 and 6 from the lesson, which I will go over. Don't stress. Okay, I circled it. So as you can tell, this is going to be our c value. Okay. So it closely relates to the second example I wrote down. So -2 would be c and -4 would be c. So what does c actually do to these graphs? Well, what they're going to do is they're going to shift the graph up or down depending on whether it's positive or negative, or subtracting or adding. So if you subtract, you go down. If you add, you go up. So here we would shift down 2 units. Here we would shift down 4 units. If this was a positive, we would have shifted up. Okay, so I hope that's very clear, but it should make more sense when we cover those 2 problems in the lesson. Finally, y equals negative 4x squared plus 2x minus 3, where a would be negative 4. Y equals 2x squared plus 5, where a would equal positive 2. So I really want you to notice that this is a positive 2, even though they don't put a plus here. It's still a positive number. That's important to know. And then y equals negative 3x squared minus 4x plus 3, where a is negative 3. So negative 4, negative out front will make this thing face downward, or a sad face. Positive numbers will make it face upward, like a smiley face. Notice, mistake. And negative 3, it's going to face downward since it's negative, so it's going to look like a sad face. All right, so I'm going to give you guys just a second if you want to take a picture, pause, whatever you want to do, as I load up my canvas. So what I have done is, again, let's take a moment to appreciate the party dog. I went ahead and wrote out all of the problems on a piece of paper, minus some of the answers. So we're going to go through and fill them in. So if you're looking at number 1, you should be on Canvas. You should be looking at question number 1 on lesson 9-1, so it'll be easy to follow along. So as we go through, question number 1 says, identify the vertex of the graph, tell whether it is a minimum or a maximum. So we have a sad face or a downhill one. So if we look at our graph, we're looking for this point, and we know it's going to be a maximum. So how do we find this point? Well, when we list points, we list them x comma y. So 1. Oh, this pen is out of ink. Luckily, I have a pretty pink one right here. So we go over 1, and we go up 2. And then, since it's uphill, if you already forgot about the notes, that is a maximum point, so this will be a maximum graph. So I'm going to write max. Moving on to question number 2. I'm after this point. Right here, we listed x comma y, so we need to go 1, 2. And we go down 4, so down is negative, negative 4 for y. Since it is a smiley face, it has a minimum value, meaning this is the lowest possible point it goes on this graph. So we have a minimum. So far, so good? Good, I'm glad. Now, number 3. It gives you a graph, and it kind of talks about the difference between this function and this function. So what are the differences? If we look back on our notes, okay, if you look at these 2 functions, what's the difference? We have a minus 2 here. So if we look at our notes, problem number 3, what does that minus 2 do? Well, it shifts it down. So as we go through and look at this, we should already know, hey, this one is this graph shifted down 2 units. So they gave us x values. Where did they get these x values? They just came up with them off the top of their head. 2, 1, 0, -1, -2. Those are easy numbers. They didn't plug those in anywhere. However, these numbers do mean something. So they gave us a 2. How did they get a 12? Well, if we take 2 and we plug it in there, what do we get? I take 2, I plug it in here. What's 2 squared? 2 times 2 is 4, times 3 is 12. That's where they got the 12. So what do we need to do here? We need to take this 2 and plug it in. So I went ahead and I did that. So I plugged it in, 4x, 2 squared is 4, 3 times 4 is 12. 12 minus 2 is 10. So what goes in this box? 10. Now, does that make sense? Is this shifted down 2 units from this? Yes. 12 and 10. Those are 2 units apart. This is 2 units less than that. So, could you make the assumption that these values are going to be 2 less than all of these values? Absolutely. That would be absolutely correct. So, I want you to go through and note something. Now, I did make a mistake right here. This is supposed to be a positive 12. Again, if you're looking at Canvas, this is the number they gave you. All right, so let's see what happens. If I plug in 1, they gave us 1 over here, so they must have plugged in 1 here. 1 times 1 is 1, times 3 is 3, minus 2. 3 minus 2 is 1. So we should plug in 1 here and get something 2 units bigger than that. So I did the work here. I plugged in 1 for x on this side, right? 1 times 1 is 1. 3 times 1 is 3. So 3 goes here. Does that follow our initial assumption? Is 3 2 units bigger than this? Yes. Or is this 2 units shifted down from 3? Yes. So can we fill these in without even using any more substitution? Absolutely. And I kind of encourage it. I want you guys to use more logic, more deductive reasoning. So if I know I'm going to shift this down 2 units, 0 minus 2 is negative 2. Could we check our work? Yes. What's 0 times anything? 0. So 0 times 0, 0 squared, is 0. 0 times 3 is 0. And what's 0 minus 2? Negative 2. Okay. Same thing with this. This side should be 2 units less than this side. So this is going to be 2 units more than this. So what's 2 units more than 1? 3. Is it a coincidence that this matches this? I want you to think about that for a second, okay? I'm not going to cover that right now, but you will see that in the next coming lessons. There is no coincidence, okay? Spoiler alert, you're going to have 2 of the same answers. Again, you can forget that. I'm just kind of giving you a little head start into the next lesson. So going back to the problem at hand, sorry for going on a tangent. If this is 2 units more than what this should be, if this is supposed to shift 2 units down, what's 2 less than 12? 10. 12, 10, 12, 10. All right. So again, I want you guys to kind of experiment with that or do your practice. You will get enough experience with that as well. And now let's move on to the next questions. So, question 4 and 5. I want you to see the notes. What notes? These ones. And problems 1 and 2. It's the same thing. Problem 4 and problem 5 ask you to find the vertex and tell whether it's a maximum or a minimum. Well, look at number 4. Does it match this one or this one? And then count the points. Question number 5. Does it match this one or this one? And then for the vertex, count to the point. Okay? So that's what I meant by check the notes. Now, problem number 6. We have, let me find it really quick. All right, question number 6. It says, graph y equals x squared and y equals x squared minus 4 and compare the 2 graphs. And then it says to complete the statement. So it says the statement is as follows. The graph of y equals x squared minus 4 has the same shape as the graph of y equals x squared, but it is shifted blank 4 units. So if we look at our notes, and we look at these problems, we have y equals x squared and y equals x squared minus 4. So what is c? Minus 4. What does c do? Shift the graph up or down, based on whether it's positive or negative. So our c is negative, so it's going to go down 4 units. So to finish the statement, it's going to shift down 4 units. Easy enough. Moving on to question number 7. Question number 7 is a true or false, and I'm probably going to over-explain it, but honestly, I don't really care. So here you are. You can either skip forward or listen. So it says, tell whether the statement is true or false. Positive values of C shift the vertex up. Negative values of C shift the vertex down. Literally what I was just talking about for this problem. So again, if we resort back to the standard form, ax squared plus bx plus c, we're really only caring about c. So this is how we shift it. I hope you guys have a song stuck in your head now. So if we look at the c value, it is going to tell whether it shifts up or it shifts down. And it should be fairly straightforward. If it's positive, we go up or increase. If it's negative, we go down or decrease. So positive C goes up, negative C goes down. So the statement again, positive values of C shift up, negative values of C shift down. That is a true statement. Number 7, true. All right, moving on to number 8. Now number 8 has this beautiful box. So as you can tell, my lines are absolutely beautiful. And I went ahead and I filled out the answers for you. Now I did this for one reason. I don't want you guys to get confused with the decimals, and I want to give you guys the answers so you can try for yourself and see if you can get the answers that match mine. So it gives us the story about a monkey dropping an orange from a branch 26 feet above the ground. The force of gravity causes it to go down, and so on and so forth. So we're going to learn more about this in question number 9, but I want you guys to note a few things. Before we go into this, should this parabola face up or face down? Well, it's negative, so it should be a sad face. It should face down. Okay, should it be shifted up or should it be shifted down? Well, this is positive, so it should be shifted up 26 units, excuse me. So I want you guys to keep that in mind. It's not important for this problem, so yes, I wasted your time, sorry, but it is important for the next problem. So as you go through, I have these. How do you find them? You plug them in. So I always use the example they give you and try to show you how they got what they got so that you can replicate it and get your own answers. So what did they do? They have t here as 0. Here is t in the function, so they just plugged it in. What is 0 squared? 0. What is negative 16 times 0? 0. What is 0 plus 26? 26. That's how they got 26. If you were to plug this into there, you would get this. If you plug this into there and solve, you would get this. And yes, I did mess up. So again, can you cheat and just steal my answers? Absolutely. Is that going to help you on your practice? Absolutely not. So you might as well try a few of these and see if you can match the answers. I would try these bottom 2, as those give you nice clean 10s and 1s. I like them. So just keep that in mind. Now, moving on to our last problem, which I am excited about. We have a squirrel in a tree, and this squirrel drops an acorn. So I went ahead and drew a beautiful tree, as you can tell, beautiful tree. And this squirrel, yes, it looks like a stick person, but it's actually a squirrel. And an acorn, which I do have to say is a beautifully drawn acorn. And of course the ground for reference. So why did I draw this? Well, 1, I'm bored, but 2, it actually is here to prove a point. So if you're thinking about real world problems, we all hate word problems. We all hate real world problems. No one wants to go to the grocery store and buy 40 watermelons. Okay, but this one I like. It actually makes sense. If a squirrel were to drop an acorn off of a tree, would it go down or would it go up? Well, in our universe, it's going to go down based on gravity. So as you can tell, it should look like this, somewhat. Kind of tossed it out, right? They shouldn't say dropped it. They should probably have said tossed it, but nonetheless. it's going to make a parabola. Now, Thompson, why are you over-explaining this with a drawing? Because you're given 4 answer choices, and instead of graphing this thing and taking your time to try to figure out how to plug in numbers and do a T-chart and plug in points and all of that greatness, you can just use logic or deductive reasoning to find out what your graph is going to look like for the most part and then match it. So let's look at it. What is it going to do as far as shifting? It's going to shift up or down, up 24 units. So from 0, is it going to shift up or down? Positive, it's going to shift up. So it should be right around here. Okay. It's going to go downward or face downward, sad face, because this is negative, right? Based back on our notes. We have our shifting and whether it faces downward or upward. This is negative, faces downward. This is negative, faces downward. So right off the bat, I know it's going to look something like that. Now, because it's a parabola and this is extracted from a real-world problem, we do have the negative side, which doesn't necessarily exist in our squirrel example, but let's say he tossed it both directions at the same time. This is what our graph is going to look like. How do you match it to yours? Well, does it face up or down? Down. Does it start on the positive y-axis or down here on the negative y-axis? Well, it's a positive 24, so it should start on the positive. There is only one answer choice that is on the positives. So I hope that's very clear. You can do this by plugging in the 1, 2, 0, -1, -2 from the previous problems, but ultimately I want you guys to get more practice in kind of thinking about this in a real-world situation. So that is all for this lesson, okay? Again, I'm going to bring the notes back up to this page. I want you guys to go ahead and try the practice on your own. Go ahead and email me or leave a comment or whatever if you want me to go into any of these problems further, or if any of the practice problems are a little bit difficult. Thank you for watching. Have a good day.